Hi guys, can you hear me first or not? Okay, very good. Thank you very much. Okay, welcome to week 7. We just basically did the first midterm last week. So I'm glad that almost everybody had, took it, because there was a couple of people who, for some reason, they couldn't take it. Anyway, we have embarked already in the second part of this course, and we moved away from basically the foundations that we laid before, and we entered into the solar system. So this is basically where we are right now. We're going to conclude the solar system very soon. So probably next week or so, we're going to be finished with it. We're not going to be able to do every single planet in the solar system. Every single planet is worth basically a whole topic by itself. And the book that you have has a lot of units, and each unit is actually dedicated. There are several units that are dedicated for each planet, and dwarf planets, and moons, and asteroids and comets. And if we do that, if we really try to spend time on each and every one of them the way that it's laid out, we will not be able to finish the material by this semester. In other words, we will not be able to do the stars and parts of the galaxies and the universe and all kinds of other things that we are hoping to achieve. So the plan in here, we're going to be selective. We took already the Earth, and we studied it a little bit more in depth. Today, what we're going to do is we're going to take the moon of the Earth. And it's an interesting object by itself because, for one thing, it's an odd object to have in the solar system. The fact that the Earth has a moon is an exception. And you will see why, basically. We already alluded to it and talked about it extensively, as a matter of fact, before, when we were talking about the solar system and the different parts of it, the components of it, and so on and so forth. Inner planets really do not have moons. Even Mars, basically, if you can call those things are moons, they are not. They're captured asteroids, and they're too tiny to be considered the same caliber or the same size of the moon. Then I was really, and I always already came up with that call. The debate is honestly between Venus as an interesting object for us to study, or Mars. Okay, so I made the call for Venus, and I will tell you the reasons why. Okay. Mercury is never usually an issue because Mercury is too far close to the sun, and it's not really, honestly, for us immediately, it's not of a great interest. There is a lot of manned missions not manned missions, actually robotic missions to Mars. We sent orbiters. There are several orbiters right now. The last one was sent by the UAE in 2021. Okay. So, and it actually arrived on Mars the same time when Perseverance actually landed on Mars. So that's the other mission also at the same time. So Perseverance, which is a lander by NASA and the European, Space Agency, they basically cooperated, including also the Canadian Space Agency, to have a lander in there, and that lander, Perseverance, has a helicopter component of it, or actually a drone component of it, and it's studying extensively Mars. And that's not the only one, actually. During the same time when they went to Mars, actually, there was a Chinese mission that landed also on Mars, and it had also an orbiter around it. So Mars is heavily studied, and these are just the most recent of them. There are far more in the past, including some others in the past that are still ongoing. The two, or at least one of the biggest ones, is InSight, that landed in 2017, and InSight actually sent a probe inside the surface of Mars to study its internal structure by listening to the quakes on Mars, which is Mars quakes, and trying to study the composition of that planet. So Mars has basically attracted the interest of the humans for a long time in terms of investments and in terms of missions to it. So it's still an interesting object, and there are far more also in the future of that planet for it. But this is not actually the closest planet to Earth. I mean, if you really go to the line of sight, when it's as closest to Earth, actually Venus is closer. But there is another reason why Venus is of interest. Venus is almost the same size as Earth. Slightly smaller than Earth in terms of size, in terms of diameter. So it looks the same size of Earth. And then it's also in terms of mass, it's slightly less than Earth. In terms of gravity, it's slightly less than Earth. But that's basically where all the similarities end. It is really the worst place. So yes, it's a twin planet to Earth in terms of when it was formed and how it went about it and all of that. But there is an evil side to it, if you wish. Okay, it has a greenhouse effect that is really, really, really extreme. Okay, so it's of interest to us right now because the biggest question is what happened to Venus? Could it happen to Earth? Okay. And that is one of the key questions because we want to learn from the experience of Venus, because Venus at some point in the past, according to a lot of studies, was not different from the Earth. It has oceans, it has land, it was very much suitable to life. And if I were to compare between Venus and Mars, Mars is slightly smaller in size. Mars also evolved liquid water on its surface. We know that for a fact. Mars also was habitable. In other words, it could have sustained life in its past, but its habitability did not last long enough. It did not really, because it's smaller, so it did not really maintain its atmosphere long enough for life probably to evolve. And if it did evolve, it really stayed in a microbial form. The point being in here is Mars lost all of its atmosphere because it has weaker gravity, so it couldn't really hold on to it, so it lost it. In addition to the fact that it is smaller also, and yes, it lost a lot of its heat, the one that it got from when it formed, and also it does not have a lot of radioactive materials, comparatively speaking, because it doesn't have a lot of mass. Proportionally, it should have the same proportions. But because it starts with a smaller mass to begin with, so it could not really have that inner heat, inside heat, to generate enough strong magnetic field to shield the planet from the radiation that is coming from the cosmos, especially from the sun. So Mars did not really have a good, if you wish, a good things going for it. But planets Earth and Venus, both of them have everything going for them. In terms of mass, at least, they could maintain their atmosphere. And they could also regenerate it because of the outgassing, because of volcanoes and earthquakes and things like that of this nature, that releases more of that gas that is trapped inside through those eruptions. So these two planets have evolved in a similar fashion. And Venus, for up to about 150 million years ago, according to some studies, or probably 500 million years ago, according to others, it was similar to Earth in every which way that you can think of. But something went wrong in a sense that there were a lot of volcanoes on its surface that released a lot far more gas than basically that basically saturated its atmosphere. And in doing so, the radiation coming from the sun, it comes in all of the radiation that is basically all the wavelength. And it's not really the proximity, it plays probably a slight role in the beginning, the proximity from the sun that plays a big role, but it's really the fact that it has a big atmosphere. So the radiation goes from the sun, comes from the sun, goes into the surface, heats up the surface. Because the surface now gets hot, it emits back the radiation to the atmosphere. And the radiation that is emitted back is of a longer wavelength. So that radiation that is emitted does not penetrate the atmosphere to leave the planet Venus. It actually bounces back. This is what is known as a greenhouse effect. Short wavelengths can go through the atmosphere, they're absorbed, and then when they're emitted, they're not emitted in the same wavelength, they're emitted in longer wavelengths. So they don't penetrate through it, so like an opaque material, so they bounce back. And that led to the planet heating up. So in a sense, that scenario, what it did is it raised its temperature further and further and further. When it did that, the water that was into its surface starts to evaporate because of the higher temperatures. Not only that, but the water starts to break down into its components, hydrogen and oxygen. Hydrogen was lost in the atmosphere. It was lost to the outside, basically. That's how Earth also loses its hydrogen also, because it's lighter than oxygen. no matter how much gravity, you cannot really hold enough to it. And so it lost most of its basically water, because you need that hydrogen to recombine back to form water. Now that oxygen that remains in the that was broken down, it went back and combined with carbon, and now the atmosphere of the planet is mainly carbon dioxide with sulfuric acid. So the planet right now is really, if you were to go to it, or if there is a living organism on its surface now, it cannot sustain the temperatures. The temperatures is the hottest temperature in the solar system, other than the sun, of course. I'm talking about planets and things like that. It's the hottest planet. The pressure there is tremendous. It's 92 times the atmospheric pressure on Earth. It's suffocating because of carbon dioxide in its atmosphere, and it's also burning because of the sulfuric acid, which is going to burn any organism that can be there. So the planet in itself is a hellish word, really. You cannot really think, you cannot imagine how bad it is. We have managed to have landers, actually. The Russians had a couple of landers. One of them lasted for a couple of hours, the other one for about, I think about an hour or so. And they sent pictures back to Earth, and they melted after that. They couldn't really, they could not resist the temperatures and actually the pressures that are from the atmosphere at the end. But the point being, we have a lot of information about that planet, at least in the beginning. And then there was 2020, when everybody was busy with the with coronavirus. Phosphine was detected, or at least claimed to have been detected in its atmosphere. Phosphine is a compound that basically that can exist due to one of two processes, either a natural process, or a non-organic process, or organic matter, living organism producing it. That's how we know it produced here on Earth. So that is really something that is kind of, what kind of organisms, if there is an organism in there. Now the study itself is a little bit questioned in terms of the quantities, but the large quantities that were initially detected, or at least reported, suggest that there is life, organic life, the life that we know here on Earth. If it's not on the surface, and probably it's not on its surface, probably it's in its atmosphere. So whatever remnants of that water that evaporated from its surface, probably this is a scenario. This is not a exact. It's just a speculation, if you wish, at this point. So there was some of the lives basically maybe hung into that water and started to live in its atmosphere. You're asking me what happened to the pressure. Well, it's in the atmosphere. The pressure is actually better in those heights. What happened to the temperature? Well, it's high enough in the atmosphere, so the temperature is not that high. What happened to the sulfuric acid that you were talking about and making a big fuss over it, that it's so damaging to living organisms? Speculation is that this life form, if it exists at all, may have developed a shielding around itself to protect itself from that acid. So maybe that is what's going on with these things. Again, it really now, if you wish, brought up the Venus back to the front of the studies, and now there are more people interested in it, and actually there are missions planned by NASA and others to have missions at least to go to its atmosphere and study the planet more and see maybe there is something of interest to it. Again, for us in here on Earth, the reason why we really want to study it is to ask the following question. Is what happened to Venus could happen to Earth? And the answer is absolutely yes. Okay. Maybe there was comets or meteorites that hit the planets. They're big enough that triggered those volcanoes, that release that much gas. And if that's the case, then this scenario is also very likely here on Earth, because we have the same processes. The other difference in here in terms of Venus, we don't think that it has plates like the Earth is. So there are some interesting things trying to see if we can at least if we can really prevent what happened to to Venus to happen here on Earth, at least to see if we can mitigate it, if you wish, or do something about it. That's one thing. There was yesterday a mission. I hope you guys were watching the news from DART. That's a NASA basically project. One of its purposes was to hit an asteroid and see the impact. It hit it with so high speed to see if we were able to at least change the path of that asteroid. So again, at this point, we really don't have a lot of data. NASA is waiting for the data because before DART went in and fell on the asteroid, it left actually a probe behind it, and that probe was supposed to take pictures and send data. So they are still analyzing the data to see what's going on in it. So again, what we're saying in here is Venus is a twin sister to Earth. Something went completely wrong in its past, that right now it's completely inhospitable to life. And we want to learn from it, and that's really the purpose of including Unit 41 in your schedule in here, instead of going to Mars, which is heavily studied right now. There's a lot of information about it. And Perseverance, actually, which was the mission that landed in 2021, in February 2021, that is actually something that's still sending a lot of data information about the past history of Mars, and basically what is almost proof of an existing, or at least in its path, of life on that planet. So, and that is an interesting question by itself too, in the sense that here is the case. You have planet Earth. We know Earth was habitable, it could sustain life, and sure enough, life evolved on it. There is Mars. And at some point in its past, it was also habitable, could sustain life. And if this current data from Perseverance is really confirmed that life actually evolved on it, so it seems like 100%. If you have conditions for life, life evolved on Earth. If you have conditions for life, life evolved on Mars. Then it seems like whenever you have conditions for life, life can evolve. That is really the big question, the big answer to it. That is really what is interesting from all of these things. But we're not going to spend a lot of time. We're actually not going to do Mars at all. Sounds good, guys? Good plan? Okay, very good. Thank you. So let's delve into, thank you, Susan. Let me delve into the unit to make sure that we have everything in here. I mean, good thing about this week is, other than the discussion session, there is no homework assignment and everything else. There will be a homework assignment next week. And that homework assignment will deal with Venus itself. So we're not going to be able to cover the problems from it until next time, till next week. And it has to do with the rotation of Venus, okay? Rotation of Venus. And because it goes around the sun as everybody else does, but in the same time it's spinning clockwise on its axis, not counterclockwise, like everybody else on their axis. And with the exception, of course, of that from what we learned, Uranus is actually spinning on its side. I mean, it's going on the side, and like everybody else, that is spinning on its head, basically looking up, with the exception of Venus, that is spinning on the head basically bottom, and the tail is on top. So that is basically the thing that is going to be a homework assignment. So again, we're going to discuss the problems in class. So hopefully you guys will join. And there was a question actually from some of you guys in the class about those homework assignments, and they couldn't really find the resources. Again, if you watch the Thursday sessions, the Thursday recordings, and if there is a homework in that week, you should be able to get enough information to be able to do that. And if you still are not sure about it, please reach out so that we can have them clarified. Because as I mentioned before, and I mentioned it several times, I believe in the power of the homework to reinforce basically what we learn in the lecture. Because unless you pull on your sleeves and you actually do things, those things that you learn are just going to be something basically like stories, okay, without any kind of meaning to them, as much depth as you should really do. And the only way to do it is by just actually working the numbers, okay, doing stuff. Okay, so let me share the PowerPoints from today. And it's unit 39, where we're supposed to be. Find it. 39. Let me go back into the beginning. So it's all about the moon, okay? And its surface and its main features. Okay, there are two basically. There are several features actually. There is the Marias, and those are. It's actually a Latin word which really means like seas. Okay. I need some help from the people who speak Spanish in this class. How do you say sea in Spanish? You can type it if you want to. Guys don't know? Let me tell you how it is in French, okay? And it's read mer. That's also it. Anybody? Or there is no word for sea in Spanish? Or you guys don't know Spanish, so it's fine. Okay, never mind then. Seems like we don't have anybody who can help in here. Anyway, so I think this is a Latin word, Marias. So that's basically refers to the seas, because when Mr. Galileo looked at the moon, and actually you can go tonight and look at it, okay? And don't forget you have an ongoing project for the lunar observation, okay? So don't forget that you have your observation, and I'm glad that I remember that because it's part of the topics anyway. So you have your observation that you're supposed to do tomorrow, okay? Yes? So when you go and look at the moon, you will see dark places on its surface, okay? And those are big patches in it, on its surface. Those are the Marias, okay? Which is really a Latin word, which means sea, okay? And they have names like Sea of Tranquility and other names in there. So they have all kinds of names in there. So that's basically how they were named. So when he looked at it, when Mr. Galileo looked at the moon with the telescope, of course, you could look at it with the naked eye and see the same features, but he looked at them and he saw what they're kind of, what looks like it's like smooth surfaces. So he thought that, or at least he gave them that name. And then also, or at least that's how the speculation was. And then there are also the impact craters on its surface. One of the biggest features actually on the moon that you can see is Tycho crater, which is actually from the southern side of the moon, and it spreads and it has all kinds of basically features throughout the entire moon. So that's a huge structure in there. So you have craters and you have kind of all kinds of features on its surface. So it's heavily cratered, and it's not as much cratered on this side, or at least the visible side to us, as on the opposite side, okay? So this is some of the features of the moon that we're going to be talking about them and how they form. Up until like the 1800s, people believed that there is life on the moon, that there are actually inhabitants of the moon, and they were kind of thinking, maybe speculating that there's things on it. And the idea was around the beginning of the 1800s, or around the middle of that time, there was an article, I believe it was in the New York Times or something, one of the magazines at that time, or newspapers, that Herschel, who was the famous astronomer at that time, saw civilizations basically on the moon. And Herschel at that time was actually in South Africa doing other observations, because at that time there was no communications, no nothing. So people believed it, that there are actually living people on the planet, but on the moon. But then, of course, there was counter arguments with it. If there are living people on the moon, where are their lights, where there's activities that we could see, and of course we couldn't see it. Obviously, that was a hoax, and that's not true. The moon is barren. It does not have any kind of, at least no liquid water on it. Those seas are not seas of water. As a matter of fact, what happened, the early impacts that hit the moon they were so powerful that they basically caused the lava to flow to the surface, and that is the lava basically that solidified at the end and gave the color of that of the surface, or at least the smoothness of that area, those areas. So the moon was geologically active in the beginning, just like any stellar, like just any other object in the solar system. So that is basically the extent with it, but it was too small to be able to sustain that geology, that activity for a long time. So it lost everything else. Now, there is another thing also of interest for the moon for us. It does not have an atmosphere. So whatever atmosphere it had, it lost it immediately because, again, I was talking about Mars and the fact that Mars could not sustain a lot of its atmosphere. Mars still has an atmosphere, but it's a very, very small amount of atmosphere. And it's mainly also carbon dioxide, but the moon does not. The moon is basically barren, as I was saying, and its surface is very dusty because those impacts from the asteroids, they basically released a lot of the dust, and that dust settled on the surface. There is water, but not in the liquid form, especially in near the poles of the moon, but it is actually solid water. So that's one of the missions that, at least the Artemis mission, that is planned to be there on 2025, is to see where the biggest amount of water, at least where the places where we can go and land and extract that water and basically liquefy it and use it for a lot of things. Basically, first of all, for the consumption of the people who are going to be stationed there, and also for the to extract oxygen off of it, because you would want to, the plan is actually to do missions from the moon toward Mars and other places in the solar system, or at least come back to Earth if you need to come back to Earth. So you need the oxygen in there from the water. So this is basically the, and there are huge amounts of it according to the current estimates. Okay? So this is basically of what we know in terms of unit 39. So the stuff that we have in here and going on for the moon. This is in its surface. And then how the moon came to be. And again, this is one of the biggest questions that need to be answered. And it's a very legitimate question, and somebody has to really, really answer this one. Because, again, as I was saying before, Mercury doesn't have a moon. And it's an inner planet. Okay? Well, you might say Mercury is too close from the sun and probably whatever. And it's not that close, honestly. I mean, you have planets that we're discovering that are far, far closer to their host planets than Mercury is. Okay. And then what happened to Venus? Venus is big enough and it should really have a moon. I mean, if this is a common feature, but doesn't have any. Okay. And as I was saying in the beginning, Mars has two tiny, very, very small. They really should not be qualified, but because they are satellites to Mars, we call them moons, okay? Phoebus and Deimos. The thing with these two is they don't even have spherical shape. They have deformations that look more like asteroids. So that's what we think, that they are two captured asteroids, and the asteroid belt is not too far from Mars. And those, they could be basically pushed back by Jupiter, and they were captured by Mars. So that's basically what's going on with that. So we don't have, inner planets typically do not have moon. And here is Earth, the third planet, having not only a moon, but a huge moon, relatively speaking, a big moon, okay? So we really need to understand where the moon came from. Again, the answer to that right now, or at least the leading theory right now to where the moon came from, is in the region where the Earth formed, there were two smaller planets. One is bigger than the other, relatively speaking, and one of them is going to go and become the Earth as we know it today. And the other one was actually in the same vicinity, was another planet, and they gave it the name Theia. Theia was close enough from the Earth, so at some point orbited and then smacked into Earth, and it smacked right in the right angle. Okay, for the simulations nowadays, it has to really hit the Earth on a specific point in it. Okay, and that collision resulted, that impact basically resulted in a lot of material scattered around the Earth. So at some point, the Earth resembled Saturn, because it has basically like a ring structure around it. Okay, so it has a lot of the dust that formed around it, and it was spinning around the Earth. Some of it fell back on the Earth, and that collision produced a lot of heat on the Earth. And then others started to coalesce, and as it coalesced, the further it coalesces, the more matter is going to attract to it, and then that became the moon. So that is the leading theory in here, and that is the impact theory. Any other theory would not support the current observations. One of the other theories is that the moon and the Earth formed in the same time from basically the same things, but they should really have evolved, and the impacts later on, they should really give them a little bit of differences that we don't see in terms of their composition. So there are a lot of similarities that suggest at some point they were connected to one another, okay? So another hypothesis that basically it's a captured also object. So it was really a object that formed, and again, now it's spinning around the Earth because it was captured by the Earth. That is not supported by also the same thing, the composition, and also the fact that it's actually receding right now from the Earth, okay? It's moving away from the Earth. So at some point, it was very close from the Earth. The moon plays a major, major role in, first of all, the existence of life on Earth, because it is the one that regulated the formation, first of all, of the moon caused that tilt of 23.5 degrees, which is the reason behind the seasons and the fact that we have all kinds of sustainability for life in here and so on and so forth because of the seasons and the cycle of water and all of these things. Not only that, but it's actually the fact that you have this motion around the Earth that is actually causing a lot of that regulation and preventing the tilt, if you wish, from going back and staying at 0 degrees, because then you will lose all the seasons, or at least from having a wobble of that tilt. Because if it's wobbling back and forth, the conditions on Earth will dramatically change from being extremely cold to extremely hot, and in doing so, the temperatures will be on one of the extremes on one side and the other extreme on the other side, and that will not be able to support life as we know it, at least on this planet. So the presence of the moon plays a major role in the existence and the sustainability of life on the Earth. So that is some of the exceptions. And again, I just mentioned the theory that will believe how the moon formed, and that is the leading theory, and that is called the impact theory. Okay, so the planet was given a name, and it is named Theia. Okay, so again. So these are the different theories for the formation of the moon. So a successful theory must explain the moon's composition and orbital properties, including why the moon is slowly moving away from the Earth. Because if you're telling me it's captured, then how come it's moving away then? So that's not true. So many theories have been proposed about the origin of the moon. The moon was once an independent planet, but was gravitationally captured. The composition was too similar to the Earth for this one to even happen. Because if it was captured, they should have different compositions from different places. The twin theory, the moon formed at the same time in the same place, where the composition of the moon is different enough from the Earth that it is unlikely. Okay, so there is a composition is not from the same region, so from the out of the same stuff, because there are differences also. Okay, so you need to explain the similarities and the differences. So the expulsion theory. Basically, Earth spun so fast initially that it made up the moon. Okay, the stuff came out of it. There is actually another thing that is supporting the impact theory. If one, I mean, that's modern studies. If you look at the core of the Earth, it's supposed to be inside the Earth, the core of the Earth. It's supposed to be a spherical object. Because remember the differentiation as the heavier materials start to go inside and the lighter materials start to rise up. If you go inside, for example, and you have heavy stuff and lighter stuff and they mix them well, and then you start shaking, for example, what happened in this case, the heavier stuff will coalesce inside in a symmetrical fashion. So in other words, the core should be perfectly symmetrical. Nowadays, there are some studies that suggest that there are actually what appears to be intrusions inside the core of the Earth. So it seems like that impact, the heavy materials from it that went and penetrated the surface of the Earth, went through the mantle and continued its way all the way to the core of the Earth, and is still making its way there too. So it's still showing an intrusion inside the core of the Earth. So the core of the Earth is not perfectly spherical, but there are intrusions, I think, in the ocean near between Australia and South Africa. That region underneath has a little bit of bulge in it forming inside the core of the Earth. So it seems like the impact, that is part of its consequences. That is one of the things that led to that. So again, the impact or the collision theory is really, that can explain a lot of these things: the composition, the similarities, the differences, and even the current structure of the core of the Earth. So again, a Mars-sized object. So this Theia is not a small object. It's slightly bigger than the moon. So part of it went inside the Earth, and the other part basically formed the moon. So that's basically, if you want to find if you want to do a balance, basically. If you said you brought the size of Mars and hit with it the Earth and formed the Earth, for the moon. So what happened to the difference? Because we know today the moon is smaller than Mars. Well, the difference went inside the Earth. Okay, so that can explain a lot of things. So when the debris came off of that collision, that part of it, which is part of the Earth, formed the moon. That's why when the astronauts came from the Apollo missions, they came back to Earth and brought samples from the moon. When we looked at them, we saw similarities to the Earth matter. So that is basically how this can be explained. So it headed at the right angle, and then the debris formed, and then at the end, part of it coalesced, and then started. It's not really a big ring to really make the comparison with the moon, but that is basically what happened in here. Okay, so that is basically. So this is the day after the impact. This is how the Earth looked like. Obviously, that collision produced a lot of heat too. Okay. So this is the main features of the moon. This is the craters. This is the Tycho crater on the bottom that you see, which is one of the major features in the moon that you can look at it. It's a really beautiful sight. You can take pictures of it. Marias are these dark regions in here. They're actually lowlands. Okay. So this formed from when the impacts was so powerful in the beginning when the moon was young, that they basically magma came out from the inside of the moon and flowed and formed these features of the moon. The bright sides of the moon, the bright regions of the moon, those are the highlands. Those are like the hills, if you wish, on the moon, because they are higher, and the rays from the sun hits them and bounce back to you, so they appear brighter to us. The lowlands in this case, or the Marias, appear darker, including inside the craters, and there are some craters all around. Those because they are lowlands, and that is basically the shadows that are showing in there too. Not the Marias. The Marias are actually the big ones. The big features are actually from the magma that cooled a long time ago. Now, also there are some rays that shows the flow of matter that is coming from the impact. So this is actually the main three features. You have craters, highlands, Marias, and also you have the rays from at least the Tycho crater that is very, very visible actually on the moon. So these are some of the features on it. As you zoom closer to the moon, you will see the impacts on the surface of the moon, and they're actually superimposed on one another. So the craters, you have the ancient crater first, and then on top of it, there is the more recent craters. And when we study these ones, it indicates that the moon was subject to a tremendous number of impacts early on when it formed. Okay. So was this only unique to the moon? No. Okay. If you look at Venus, Mercury on its surface, you will see surface of Mercury in a similar fashion. If you look actually at Ganymede or Callisto, they have similar features. Any object in the solar system that did not have a resurfacing on its surface, it did not have a lot of basically geology on its surface or weathering, should exhibit similar forms like the moon, okay? So if we wish, this is like a time capsule, basically. It shows you what happened to the solar system early on. So this is what happened when the sun basically formed. There were a lot of leftover materials, and those materials, basically the smaller objects, they were thrown every which way. So they started to fall and rain on all of the big objects in the solar system, including Earth, including Venus, including Jupiter. But those, because they have atmospheres, they have a lot of them, we don't see a lot of these features on their surfaces because, again, they have cycle, whether in the case of Earth, we have water, we have wind. In the case of Venus, also, it has tremendous winds too, same thing with the other planet. But for the case of the moon, because the moon basically cooled immediately because they didn't have a lot of geology on its surface to stay for a long time. So it's kept, basically, you have a history of the solar system. So this is the early impact era inside the solar system. And that is actually the same thing, same features you can see also on Mercury too, and some of the other objects that did not have a lot of these things. If you look, for example, on Europa, which is a moon of Jupiter, or Io, which is another moon of Jupiter, you don't see a lot of these things. Why? Because on their surfaces, you have a lot of weathering. For the case of Europa, you actually have a lot of ice on its surface that is probably coming from the underneath of it because of the eruptions that are coming from the water from underneath. And those, they lead to basically the smoothing of the surface. If you look, for example, on Io, there is a lot of volcanic activities, far more than Earth does, because, again, of its proximity with Mercury. We're going to talk about that down the road. It really is, its surface is always basically changing, okay? And this is did not happen to the moon. So counting these craters and knowing their distribution will tell you the age of the surface, okay? So the age of the surface of the moon is very old, okay, compared to that of, for example, the Earth, okay? You have the craters, and all of the areas, whether the highlands, they're also heavily cratered, okay? So again, the Marias, as I was explaining before, when we were talking about it, are basically its formations from those heavy impacts that went so deep and basically pulled the magma up, and then that cooled on its surface after it flowed on its surface, okay? And this is similar. This is how the craters basically happen, okay? So in a sense, when you see the ripples on the surface of the water, this is similar to the impact craters that you see them in there. So you see inside in the middle, basically, it's a similar effect, okay? So when you have a wave that forms, the inside of it is really rising a little bit, and then you have a low area, and then you have the surface that is flipped upside down on the edges, okay? You have had a chance to go to Arizona, go and look at the meteor crater in Arizona. You will see that the surface is actually upside down because as it impacts, the lower parts will go on top, and then the top parts will go on the bottom because the surface is risen from the impact, okay? But these features are similar to how the ripples of the waves form on the surface. So this is a lava tubes. That's the flow of lava on the surface of the moon, okay? And the other side of the moon is actually, they have also a lot of impacts on them, except the other side does not have enough fewish lava flow, which is probably one of the reasons why because, again, we're going to talk about this one, how the moon is tightly locked to the Earth in a sense that as it spins, its day is the same as its night. So because it's facing the Earth on a regular time, so that is a region that is being pulled all the time by the Earth. So that's probably one of the explanations, okay? In terms of its inside, we believe the moon is similar to that of the Earth in terms of the overall structure, with the exception that the core is kind of small, relatively speaking. Again, because it's really not it's really not, it doesn't have a lot of matter to really stay hot for a long time. So the core is a little bit less, The mantle is really the biggest component. And then you have the outer layer, if you wish, the crust, like similar to that of the Earth, which has a big layer of dust on its surface, a powder basically on its surface because of those impacts that keep on hitting the moon that form on it, okay? One of the features that is kind of lacking on the surface of the moon with respect compared to that of the Earth is the lack of the what should I call it, the tectonics, plate tectonics. There are no plates on this. It's only one block. Okay. Furthermore, it's slightly thinner on the side facing the Earth than that of facing the moon, which means that when the impacts hit on this side, they could easily go to the basically release the magma and see those big features on its surface, the mareas. Whereas on the other side, the opposite side to the Earth is thicker. So even with the same impact that hits the moon on one side and hits it on the other side, in here all it does, it leaves those crater features. Whereas in here, at some point they will be deep enough to release the magma, and that magma basically for the mareas. That's why the moon has two different kind of faces that you can see, because on one side is different than the other. Okay. Again, this is how the mareas we believe formed. Again, the impact was deep enough so that the magma flow rises to the surface and basically cools down. So that's how they are formed. Okay, and this is the surface of the moon. It does not have any atmosphere at all, and it's only the dust that is formed from the moon. This is actually an imprint that was left by Armstrong and Buzz Aldrin when they landed on the moon. So this is an imprint on its surface, and this is basically when you leave an imprint, stays there forever and ever and ever unless there is another impact. And like, for example, the Earth, if you go outside, for example, to the desert and you leave your print, you come tomorrow, you're not going to see it because of the atmosphere. Okay, so it doesn't have any atmosphere whatsoever. Okay, and this is the rotation of the moon with respect to its own axis compared to the rotation of the moon with respect to Earth. This is actually a very, very important feature that you really need to remember, the synchronization in this case, okay? They are, in a sense, in this motion of the moon around its axis and the rotation around the Earth, they're the same period, they go with the same number. So when you have two periods, two motions, and they are actually the same ratio of 1:1, or 2:1, or 3:1, or 3:2, or 4:1. When you have ratios that are whole numbers, this is basically a resonance. Okay, so this is what is known as resonance. So at some point, two objects, they will be in sync, and at some point they will not, if the ratio is not 1:1. In this case, it's always 1:1 for the case of the moon. In other words, every time it spins around its axis, it takes the same amount of time to go around the Earth. That's why it gives us the same pace all the time, looking at us. But if you were to live on the surface of the moon, okay, if you were to live on the surface of the moon, you will experience a day and night, just like we experience them in here, with the exception that a day will last 14 days, Earth days, and a night will last 14 nights. One of the issues, at least when I was with some of my students in another college, when I was actually in Norco, they were working on a grant from NASA, and the project was involving actually the Artemis mission to see what can we do, the stuff that we can do to help the astronauts survive on the moon. And one of the questions was, if I'm going to put an object in there, and if we're going to have light on it, and if we're going to use power, we're going to need the solar energy. So how are we going to get energy for the 14 days, basically, Earth days that is, it's a half a day only in the moon, that we don't have energy because we don't have solar exposure. So again, you have to rely on batteries, or you have to deliver the energy somehow into the station. So the point being in here is the moon spins on its axis. With the same time, it spins on the Earth. That's why it's facing the Earth all the time in this one, this way. And as the moon, when the moon was closer from the Earth as it formed initially, it had to spin fast enough. Remember Kepler's laws? period squared. Let me try to get the pen in here. The square of the period. Remember the third law? Can you get in here? It says p squared is equal to a cubed, where p is in years and a is in astronomical units, AU. Okay. Otherwise, there is a proportion. For the case of the moon, you can still work the same numbers as long as you convert the period, which is 28 days, into years. So 28 days divided by 365. So if you're going to use the formula, this is basically what you need to do for p. Okay. And if you're going to use A is not in astronomical units, it's only 384,000 kilometers. So you're going to take 384,000 divided by 150 million. Okay. So that is the ratios that you have to use, and you plug them in this formula, so everything should work out fine. Here is a key in here. Oops. Here is a key that I'm trying to erase in this issue. Here is the Earth. Here is the moon. Initially, the moon was closer from the Earth, so it needed to spin faster. Okay. In other words, the period was shorter. Okay. So the Earth in here needed to maintain that rotation also. So the Earth was moving faster around around its own axis. So the day was shorter on Earth when the moon initially formed. And the day now, as the moon moves away, on Earth moves further away, so the moon will move slower, and so is the Earth will move slower. Remember, as A increases, P must increase also. That is Kepler's third law, from what we learn. That's why Mars takes longer to go around the sun, almost 2 years compared to the Earth, because Mars is further from the Earth, from the sun, than the Earth does. That's why Jupiter takes about 12 years to go around the sun, because it's further. It's 5 times basically the distance from the Earth to the sun. It's 5 times further away. So because of that, the days are getting longer and longer on Earth. The Earth is slowing down because the moon is receding. Remember, every year it moves back about 3.9 centimeters, about 2 inches, or 1.5 inches away from the Earth. Okay, so the days are getting longer. Okay, because as A increases, so does P, to maintain that relationship true all the time. I think this is it. I'm not going to really introduce Unit 41 at this point, because what it does is it's not going to help us basically, because we need to talk about it next time, because I don't want to break it right in the middle and then we will have a discussion. Before I close today's session, okay, there is an important event that is going on today, okay, at least for probably the next several weeks, okay, and that is Jupiter. Jupiter, remember one of the homework problems was asking you to find the angular size of Jupiter when it's as close as possible from the Earth and as far away as from the Earth. Basically, you use the formula that we discussed, alpha divided by 360 degrees equals to the size of Jupiter, which is 140,000 kilometers, divided by 2 pi times the distance from the Earth to Jupiter. Well, you are really for a treat, because this is unique to you guys. Jupiter is as close, because remember when we gave the numbers, they're at the close and the far. When it's closer, the angular size is as big as it can get. So Jupiter is as close as possible. If you have binoculars, you can look at it. If you have telescope, you can look at it, and it's actually a beautiful sight. This is as big as it's going to be. You have to wait another basically a long time from now before you actually see the planet actually for this size. Okay, so I really encourage you. I know you have the assignment tonight where you go and watch and plan your observations for the moon, and tomorrow when you actually do your observations, try to hunt for Jupiter, try to find Jupiter, okay, and see if you can find it and see it. Of course, with the naked eye, it's going to be a big star, but it's a star nonetheless, not as big as Venus, because Venus is closer. But if you have binoculars, or even better, if you have telescopes, even a 5-inch telescope, you're going to be amazed with the with what you're going to see. Sounds good, guys? Okay, very good. Okay, so I'm gonna see you guys on Thursday, the same time, and then for some of you, I'm going to see you guys on in the lab on Thursday also. So you take care, and if you have any questions about the assignments or things like that, this is actually one of the best weeks where you can catch up with a lot of things because you really don't have a lot of assignments. So hopefully you guys will catch up, and if you have any questions, please let me know. I'm gonna stop the recording. I'll see you guys.